back to me. I want to build on, in this session, on what I was started talking about in terms of the human element in process safety management. And this is a result of some very recent work and trends, really state-of-the-art trends in human factors about how we actually deal with some of the human vulnerabilities when we have humans in the system as part of our process safety management system. So it's about barrier management, and I'll explain what we mean by that in a moment, and particularly about the human factors aspects of barrier management to process safety upsets and the way we control them. And I want to introduce you to a new white paper by the Chartered Institute of Ergonomics and Human Factors, just published, about human factors in barrier management, and about how that talks about introducing the concept of human performance standards for barriers, which we've not had before, which has been an omission. So what do we mean by barriers? Well, barriers are means to identify, implement and assure measures which protect against major losses. There have been many approaches to this over the years, HAZOP, SIL, LOPA, those sorts of things we're all familiar with. More recently, bow ties have been the way to go in terms of our barrier management and process safety management tools. But what do we actually mean by the barriers? Well, just a point of terminology, what we mean by barriers are, these are good things. These are things that we want to have, which stops you getting to a place you don't want to be. So, barriers are not obstacles. Obstacles are bad things. Barriers are good things. So it's important to distinguish between the two. When I talk about a barrier, I'm talking about something that we want to have in place that's beneficial to us. Sometimes barrier or obstacle, well, it depends which your point of view is. Obviously, to the lion, that's an obstacle. To the people, it's a barrier. That fence. So yes, we could have some fun with that, but really, barriers are something that we need to have and maintain. So our barriers to process safety incidents, they should obviously be effective, reliable, robust, auditable. And there are different types. There are ones which are behaved on, based on people, their behavior, their procedures, but also hardware barriers, trips, safety valves, ESDs, those sorts of things. And remember that they have different characteristics. The behavioral ones are poor in terms of reliability, like I mentioned last time, but good in terms of flexibility, but hardware barriers are really the other way around. Very reliable, but not very flexible. So if we want them to be widely applicable, we've either got to over-instrument and over-engineer, or we can have a human in the loop and allow a lot more flexibility and efficiency in there. But you've got to know what you're doing with that and make sure it's working in the best way. So barrier performance, hardware versus human. Well, reliable performance is really what we're after here, and we do have performance standards for our hardware measures. If we're putting in a PSV or an ESD, we will have performance standards for that. We'll know what its failure on demand rate will be. It wants to be very low, 10 to the minus 5. 10 to the minus 6, that sort of thing. We'll need to know that it works in the given environment. Without a performance standard, we wouldn't implement a hardware barrier. But what do we do about the human barriers, the procedural or the behavioral barriers that we're going to implement? Do we have performance standards for those? Well, no, we don't. We've never even tried, in actual fact. If we're going to put alongside human barriers alongside hardware barriers, we need to make sure that they do actually work, that the required human performance to actually implement that barrier is available on demand. It will actually work when and where needed. And that loss of human reliability, which is inevitable, people's attention is not 100% of the time. It's very, very much worse than that. People's performance in a particularly pressure situation can actually be worse than their normal performance. We need to take care of, be appreciative of that. So, understanding that the barriers are going to degrade under certain circumstances, we need to make sure that the performance standards for those barriers are still good enough. So in the knowledge that there is an absence of any human performance standards for human or behavioural or procedural based barriers. The CIEHF have recently developed a white paper on human factors in barrier management. It's free to download, so if you don't have time to write that down, email me and I'll send you the link. You just have to register and you can download this document. If you're interested in process safety management and the human factors associated with that, then this is a document you should read. The objective of the white paper really is to give recommendations on how human performance can be considered and managed in barrier management. What I'm going to talk about in this one, because I've only got a couple of minutes left, is just the very last couple of items in the recommendations. So it's about how you might put a human performance standard together and how you might develop what we call a barrier management plan. I'll skip through this bow tie bit because I think most people in the room probably understand a bit about bow tie analysis, about understanding that there are threats that create undesirable events, and the undesirable events can then have undesirable consequences, and the idea is to put barriers in the way to make sure that the threats don't create the event, so that's our prevention or recovery. If we do get an undesirable event like a hydrocarbon release, then we've got ways of recovering that before it becomes a major problem. So those barriers, a lot of them we are familiar with are engineered barriers, again, TRIPS, CSDs, PSVs, those sorts of things, but also we will have in place almost certainly organisational and human barriers. So I'll skip through these bits because I want to jump onto the performance standards. It's easy enough to identify barriers in your system and ones that you want to have in place, but we also need to make sure that we've understood what we call the degradation factors to those barriers. What will prevent those performing in the way that they are likely to. And that's easy enough in terms of hardware barriers. You know, we know lack of maintenance or using outside of spec will cause them to fail. But what do we know about the degradation factors for our human performance? We know a lot less about that, but we do know something about it. So that's what we are really concentrating on here. So it's about, if you put together a sort of a human-based bow tie, it's about the sort of the threats from doing something wrong and what might happen if we do get it wrong, and then putting barriers in place to make sure that those poor consequences that we are worried about don't actually happen. And also then looking at what the degradation factors are for those human-based barriers and how can we make sure that they actually stand up. That really brought forward the whole concept of human performance standards for the barriers. So we have hardware performance standards, and we have, as mentioned, expectations about how they should work, but we don't have the same for human performance. Our bow ties can help us to identify where those barriers are required and how we might want to manage them. But fine, thank you. But knowing how those degradation factors can come to bear in the real world, what actually is going to undermine the human performance is something that we need to come to grips with. We do it quite rigorously for our hardware barriers. How do we make sure our hardware barriers work? How do we do that? Well, we've got planned maintenance schedules. We've got inspection, we've got testing. It's something we do to death. We do it regularly, we do it routinely. We're required to do it by regulators, and we do it as a good part of our process safety management. So we have got ways of making sure our hardware barriers actually work and carry on working when we need them. What do we do for our human-based barriers? Anything? Do we just assume because we've given somebody some training once and given them some procedures to follow that they're going to work, they're going to be maintained, it's actually going to happen, function, it's going to fire in the way that an ESD will fire after you've tested it? Well, we don't really know, do we? We're just trusting, we're just hoping. we might do things like evacuation drills. They're fairly commonplace, so that's a human-based barrier, and we will test those. But that's that's the sort of right-hand side of the bow tie. That's a recovery situation. So we might make sure that, on the right-hand side of the bow tie, our recovery human performance works because people are accustomed to it, but we very rarely do that on the left-hand side of the bow tie, our preventive human barriers. How do we actually make sure that those are working? So this really was the basis of providing some human performance standards in the barriers white paper, and how we might start to put that together. It's complex. It's not a one-size-fits-all. It's not as simple as having a planned maintenance and inspection and testing program for our hardware factors, because we're dealing with humans, which are rather more complicated than pieces of engineering. But things can be done. You can put together factors such as obviously training and competence levels, but what determines whether it's going to work? What sort of things do we need to consider? Well, it's things like who's detecting a signal, who's deciding what to do, who actually makes that action, what information is needed to make that action, what are the key judgments or decisions that need to be made, in what timing, and what feedback to those actions and decisions need to be given. How do we actually map those things? Do we actually know that all these potential vulnerabilities are not going to come to bear, and that we actually are controlling and managing them in the same way we might do, corrosion or rust or something else in other parts of our engineering system? So these are the sorts of things that start to build up our human performance standard. You're not expected to read that, but that's just an excerpt from the white paper, which gives a bit more detail on the typical contents or sample contents of a human performance standard for a barrier which identified on a bow tie. Also want to talk about the concept of a barrier management plan. So if we are going to make sure that these barriers are robust and reliable and they work when we want them to, then what we call a barrier management plan is a recommended practice. So having a barrier management plan for our critical tasks, particularly on the left-hand side of the bow tie side, is something that's recommended in the same way that we would have preventive plan maintenance for our critical equipment. So what would we put in our human performance barrier management plan? I mean, to some extent, I've already mentioned that we do this less, or if at all, we do it much less than we do on the human side than we do for the hardware side. But considering what I said earlier about the human reliability versus equipment reliability, we ought to be doing a lot more. The failure on demand for the human performance is going to be much greater than it is for our hardware failure on demand, but we are not actually checking or testing this to anything like the same degree. The stats would say we ought to be doing more of it, not less of it. So how might we do that? And we're nearly concluded now. What sort of things might you want to include in a barrier management plan for human-related barriers? Well, obviously things like the critical tasks, the things that if they do this wrong, bad things will happen. Distinguishing that from, making a mistake at one part of the process won't upset us very much, in other parts it will very much. Identifying job roles and responsibilities, the human-machine interaction, the availability of personnel. Are the people that we need to do the second-person checking always available? For example, the sort of sharing responsibility, workload. If you've got a control room operator in the control room in a critical situation, is he now asked to divide his attention 3 ways, which is going to be impossible? Have they got the right level of competence? Are the critical communications channels always available when we need them? Is there capacity for learning and improvement and management of change? These are the sorts of things that you might want to consider in a barrier management plan. And again, there's more information on that in the white paper. So just in terms of our concluding remarks then, the white paper introduces the concept of human performance standards for process safety management barriers and the concept of a barrier management plan. It provides some guidance, but it's not as simple as putting in a planned maintenance. There's no one-size-fits-all, but we can start to make a difference. And it's good human factors principles that underlie this whole approach. So thanks very much.
Thank you very much, Ian.